Hey everyone, it's Larson in the lab, and right now we're doing station one of our Properties of Water lab. What I've done is I've already gone ahead and set up some of the materials. I have two Erlenmeyer flasks here. They both have thermometers in them and they have different liquids. This one has pure water and this one has vegetable oil. Now, right now, both of these are measuring at 24 degrees Celsius in temperature. So what I'm going to do is on my data sheet that I'm going to put a picture of in your lab activity, I am going to record that at 0 minutes using heat, we are at 24 degrees Celsius. You can see that here, and I'll upload this document as we continue to work through this lab. So what I'm going to do for the procedure here is, because I've already measured out my water and my oil and I've put them in the Erlenmeyer flask and I've used a thermometer to discover the temperature of both of these flasks, I'm now going to place both flasks next to each other on a hot plate, which is here. It's hot, so I'm going to be careful, and I'm actually going to go ahead and put on a glove to protect my skin from heat. And I'm going to place these Erlenmeyer flasks onto this heated hot plate. And what I'm going to do is that I'm going to have them there for 5 minutes. And every 1 minute, I'm going to measure the temperature of my Erlenmeyer flask. So I'm going to begin. I'm going to go ahead and set the oil and the water side by side, and I'm going to turn on my stopwatch, which is set and counting. When that gets to 1 minute, I'm going to check the temperature of each of my Erlenmeyer flasks to see how it's changed over the past minute. And what we're going to see in this lab is whether or not the water or the oil is going to heat up at a faster rate. And then you're going to think about your properties of water and why one of them might have heated up at a much faster rate than the other one. We're about 30 seconds in, so I'm going to give it another 30 seconds and then take a look. I've arranged the thermometers using my hot hand to protect my skin so that I can see the temperature on each of these thermometers. And since I set the oil onto the hot plate just a few seconds before the water, I'll take that reading first. 10 seconds here. All right, it's time. So that is at 36 or 34 degrees Fahrenheit, or sorry, 34 degrees Celsius, and the water is at 28 Celsius. Now we wait until it's been 2 minutes. So we've got a little bit of time here, and already I'm noticing that the oil is heating up slightly faster than the water. We'll see if that trend continues as we go. Again, I'll post results in the discussion or in the lab activity so that you'll be able to see it in a table and also in a graph. We've got about 20 seconds till the next reading. Again, just like before, I'm going to read the oil right before I read the water, since I put the oil on just a few seconds before I put the water on. We've got 4 seconds. All right, the oil is now at 45 Celsius and the water is at 34 Celsius. I'm writing down my data, which again, I'll supply to you, and you'll be able to see it. When you go to do this lab activity, what you're going to be answering for this station is which property of water made one of these substances heat up much more quickly than the other. Which property of water? So if you're not sure, go back and check out the optional or supplemental activities or learning opportunities for this module on Canvas. Go back and look at the properties of water slideshow. See if you can find out which one of those might have to do with heating up faster. That's a really good hint. All right, we've got 3 seconds till we take a measurement. Okay, and it's going to be oil at 58 degrees and water at 41 degrees. And I'm measuring in Celsius because we're in science class, and in science classes, we measure in the metric units. Fahrenheit is a customary unit that's used in the United States and a couple other countries, but Celsius is used throughout the world and used by scientists, even here in the United States. So, whenever we do any sort of labs related to temperature, we're going to use the unit Celsius. Something else you might have noticed is that we are using Erlenmeyer flask here, and we're using Erlenmeyer flasks that are measured in milliliters. And milliliters is also a metric unit that would be used by scientists all around the world. We've got about 8 seconds left till we do our next reading. All right, now the oil is at 70 degrees Celsius and the water is at 48 degrees Celsius. So something that you might be noticing here is, do you see on this beaker, which is our water, it's starting to have some condensation gather. That's kind of interesting. You might remember that from the water cycle, water will evaporate and then condense. And in this case, it's condensing on the glass due to this change in temperature. Something else to kind of think about while we're waiting for the next minute to arrive in about 25 seconds is going to be, why did we use Erlenmeyer flask and not just beakers? Well, since we're working with heat, we wouldn't want those substances to begin boiling and splatter on my face and hurt me. So Erlenmeyer flask, the way they're shaped, will keep that liquid contained even if it did start boiling. We've got 5 seconds. All right, the oil has reached a final temperature of 83 degrees Celsius, and the water is finally 55 degrees Celsius. Now that concludes this 5-minute experiment. What I'm going to do is graph the data, and I will upload a picture of the raw data and the graph so that you can use that to answer your questions below. Thanks so much.